Hello everyone, welcome to NCE training session today. I am Stan from NovaStar. Our training is starting soon, and the topic today is basic knowledge of NovaStar control system. In order to provide you a good training environment, we sincerely suggest you to keep in audio mode, on mute mode during the whole session. And also please scan the QR code or click on the link at the chat room to sign in. And during the training, if you have any questions, please feel free to leave them at the chat room. And after the presentation, we will have 30 minutes for Q&A session. If you have any other questions that are not about today's content, please feel free to send an email to nce@novastar.tech. And the presentation and this video, today's training video, will be all uploaded later to NovaStar YouTube channel. I will share the link later, and please follow us at YouTube. Okay, so let's welcome Jenny of NovaStar, who is today's trainer today.
Hello everyone, I'm Jenny from NovaStar. Welcome to our NCE training. First, I'd like to start with the introduction of our NCE training to the guys who are not much familiar. The full name of NCE is NovaStar Certified Engineer. We have trained more than 3,000 individuals all over the world since it started in 2014. By giving multiple courses and valuable chances to embrace the LED control system, our NCE course will enable you to operate and maintain the equipment independently. Because of the new coronavirus this year, we hold the training online. We are hoping more techniques can get the knowledge and the certification even in this hard time. Okay, now our NCE training will have 8 courses and a final examination. You can get the online training certification if you sign in for 6 courses at least and pass the final examination. At last, I hope you guys could go to all the courses and make a good score. Okay, so this is the first course of our NCE training. Today, we will spend 1 hour together. During this time, I'll show you the basic knowledge of a NovaStar system. And we also have Q&A time after my presentation. Okay, let's start. As we know, NovaStar is a company that develops the LED control system. So let's talk about what is the LED control system first. Here, I believe some of you may not very clear about what makes up the LED cabinet. So let's talk about the LED module first. Here is some information for you to understand what is the LED module. The LED cabinet is composed of multiple LED modules, and the LED module is the smallest unit in the LED cabinet. And here we can see there are lots of electronic components on the PCB board, and this part should be designed and produced by the manufacturer. Okay, as we know, different brand of manufacturers have different LED cabinet. So we will have different type of LED modules, like the DIP, SMD, and this is the back side of the LED module. Okay, now after we have the LED module, So we need to create an LED cabinet. As the picture shows, the LED cabinet consists of several LED modules arranged according to the certain rows. And there is a receiving card and hub card inside each cabinet connected to the LED module through a flight cable. Okay, now as I just told you, normally there is only one receiving card in each cabinet, because without no receiving card, the LED cabinet cannot show any image on it. But with the development of this industry, the pixel pitch becomes smaller, so the resolution of the LED cabinet becomes bigger. So in this case, one receiving card is not enough. Our LED cabinet may have two receiving cards inside. Okay, now after the LED cabinets are ready, so we need to build up an LED screen. So as the picture shows, the LED screen consists of several LED cabinets arranged according to the certain rows. Okay, now after the LED screen has been set up, so without thinking about the video processor, if we want to display an image on the LED screen, so first we need to build up the basic structure of the LED control system. Okay, here we can see the control computer is connected to the sending controller by the USB cable or Ethernet cable. So the control computer can send the control command to the sending controller. And also, we need HDMI or DVI or DP cable to connect with the PC and the sending controller. So the control computer can send the video signal to the sending controller. And then, here we can say, the sending controller is connected to the LED display through Ethernet cables from different output ports. So the sending controller can send this video signal to the receiving cards which are on the LED display. Okay, regarding the end of a LED display, it is composed of many LED cabinets. Okay, so this is the most basic structure of the LED control system. But there is another situation. Here we can see the video source resolution is 1366 by 768. And the screen resolution is 700 by 500. So the video source resolution is bigger than the screen resolution. So the screen can only show part of the image. But here, if we want to display the entire image on the screen, what can we do? Here, we need a video processor or the software scaling, which can change your video source with the resolution 700 by 500. Okay, now after we change the video source resolution with the video processor, then the image can match your screen size. So we can get a complete display of the entire image. But here, please pay attention. Depending on the resolution, the ratio of the image may change. Okay, so this time, the basic structure should be like this. The video source came from the control computer, goes to the video processor first. And then the video processor needs to deal with the video source before providing it to the setting controller, such as the scaling function or some other functions. And for the other parts of the basic structure, they are totally the same. Okay, so with the development of this industry, the pixel pitch becoming smaller, so the resolution of the LED screen becomes more and more. Here, in this picture, we show you some common standard resolutions from Full HD to 4K resolution. And also, the bandwidth is very important in the video industry. So sometimes if you want to build up an LED screen, the limit the control system can load depends on the lowest bandwidth of all your video signal channels. So from this chart, we will show you some common standard video signal bandwidths. Okay, now after we're talking about the bandwidth, let's get into the output part. That is the loading capacity. So when we are talking about the loading capacity, we don't care about the pixel pitch or how many square meters your screen is. The total pixel number is what we need. So we only focus on the pixel level. Okay, here I have first important information for you to remember. The loading capacity of a M Control 300 is 1.3 million pixels. And we know M Control 300 has 2 output ports. So for each output port, the loading capacity is 650,000 pixels. Okay, then let's say how to get the pixel resolutions. Now, let's see an example. Here we can say the cabinet dimension is 500 millimeters by 500 millimeters. And the pixel pitch we know is 3.91. Here we know the pixel resolution, it is equal to the pixel width multiplied the pixel height. And the pixel width, it is equal to the cabinet width divided by the pixel pitch. And also, the pixel height, it is equal to the cabinet height divided by the pixel pitch. So here we use 500 millimeters divided by 3.91 multiply 500 divided by 3.91. And after calculate, we can get the pixel resolution is 128 by 128. Okay, then after we know how to get the pixel resolutions, how many cabinets can be loaded by one output port? Let's say another example. Here we can say the cabinet resolution is 192 by 192. And we know for each output port, the loading capacity is 650,000 pixels. So here, the cabinet number, it is equal to the loading capacity of each output number divided by the cabinet resolution. So it is equal to 650,000 pixels divided by the cabinet resolution. It is 192 by 192. And then after calculate, we can get the result is 17. So here in this case, for each output port, we can load 17 cabinets. But here I have a question for you. So why for each output port, the loading capacity is 650,000 pixels? Okay, actually there is a formula. Here we can see 1 gigabit is the bandwidth of each Ethernet cable, and 93.6% is the average we can use. So it is equal to the capacity multiply the frame rate and multiply the color depth of RGB. Okay, here, the common input color depth is 8-bit. And the frame rate we test at 60 Hertz. Okay, let's say the loading capacity. Okay, I'll show you. Use my calculator. Okay, here we wait a few seconds. Okay, here we can see from this formula, 1 gigabits. And 93.6 is the average we can use. Multiply. Okay, then we use it divided by the frame rate, 60 Hertz. And also we divide it by the color depth of RGB, 88824. So here, after calculate, we can get the loading capacity is 650,000 pixels. Okay, but sometimes maybe in some Europe countries, the customer may test the frame rate at 50 Hertz. So what about the loading capacity? Also, we can use the calculator to get the result. 1 gigabits. (93.6%). Divided by 50 Hertz. This time divided by 50 Hertz. And the color depth 88824. Okay, then after calculate, we can find if the frame rate is 50 Hertz, so we can get the capacity is 780,000 pixels. Okay, and also, if the color depth is 10 or 12 bit, so the loading capacity will will be cut down by half. It is because 1 byte is equal to 8 bit. So when your color depth is more than 8 bit and within 16 bit, it will occupy another byte. So our system will calculate as a 16 bit. And let's say the capacity. Here, 1 gigabits. $93.6 divided by 60 hertz. And this time, the color depth is 16, so 16, 16, 16, 48. 48. Okay, so after calculate, we can get the loading capacity is 325,000 pixels. So that's why the loading capacity will be cut down by half. Okay, so here we show you a capacity chart. So from this chart, you can see the loading capacity for each output port under different frame rate and different color depths. You can take a picture here and save it. Okay, another question for you. So what about the 4 output controllers? As we know, for 1 output port, the loading capacity is 650,000 pixels. So what about 4? Can we use the 650,000 pixels multiply 4 times? So after calculate, is it 2.6 million pixels? Okay, actually 2.6 million pixels is not correct. 2.3 million pixels is the real capacity of the 4 output controller. Okay, I think maybe you have a question in your mind. Why I can't get all the capacity? Okay, let's check it out together. Now, all our normal products are using the single-link DVI as input. And here we show you the common used single-link DVI input resolutions. And sometimes we also do some customized resolution. Okay, here we can see from this resolution, the max resolution of the single-link DVI is 1920 by 1200. So after calculate, we can get it is about 2.3 million pixels. So that's why the loading capacity of 4 output controller is 2.3 million pixels. So it is because the limitation of the input resolution. And here, please pay attention. We can also support 2 special resolutions, which are beyond 2.3 million pixels. One is 2048 by 1152, and the other is 2560 by 960. Okay, but is there any limitation of the resolution? Here, we have a comparison form for you to understand the limitation of the resolution. And from this chart, we can see these two rows, I think it is very easy for you to understand. This row, the controller mode, and this row, the total loading capacity. I guess maybe you see some old friends. And now let's say the max width and the max height. So if you check your computer's resolution, you will find the screen is within 1366 by 768 or 1920 by 1080. But if you create a new virtual screen, then the screen can be customized and the resolution should be under the graphics card. So this is the same as our scene controller. Our scene controller can also has the customized resolution. And of course, the resolution should under the max capacity. Okay, let's see an example. Here, imagine we are using the M-Control 300, and we know the loading capacity is 1.3 million pixels, and the max width is 3840. So what about the height? Okay, let's check it out. Here, we can use this formula to get the result. We can see the height, it is equal to the capacity divided by the width. So here we use 1.3 million pixels divided by 3840. And after calculate, we can get the height is 338. And another example, if we also use one M-Control 300, and this time, if the max width is 2560. So what about the weight? Okay, we can also use this formula. The width, it is equal to the capacity divided by the height. And so we use 1.3 million pixels divided by 2560. And then after calculate, we can get the width, it is 507. Okay, so I think this part is easy for you. Okay, so after that, does it mean as long as we know how many cabinets we can connect it, so the project will be no problem? Let's see a real client case. Here we can see the information. The screen resolution is 1920 by 1152. And each cabinet, the resolution is 192 by 384. And the customer has 10 columns and 3 rows. And they only have one M-Control 660. And the frame rate is 60 Hertz. So here, the question is, how can we finish the screen connection and how can we finish the cabling? Okay, so here, this is the screen connection the customer sent to us. Let's check if it is okay. Here we can see the customer used port 1 to load these 8 cabinets, and port 2 load these 7 cabinets. And for port 3, load these 8 cabinets. And port 4 to load these 7 cabinets. Okay, then we click Send to Hardware. Let's see what happened. Here we can see the software remind us the sending card number 1, network port number 1 exceed the load range. Do you want to continue? So from this information, we can see it is too much for port 1, right? Okay, actually, not only port 1 is overloaded. Other ports are also overloaded. Let's see why this happened. Here, now we have 10 columns, 3 rows. So if we try to do the screen connection like this, and after calculate, we find the blue area. The loading capacity is 192 by 384 by 9. It is about 660,000 pixels. So it is beyond 650,000 pixels. It is too much, cannot work. Then I am thinking if I can reduce the loading capacity. So if 9 cabinets is too much, so what about 8? Then I try to do the screen connection like this. And also, after calculate, we can get the blue part. The loading capacity is 192 by 384 by 8. It is about 580,000 pixels. It is within 650,000 pixels. So I think this time it should be okay. But is it correct? Here, I have a first important word for you to remember. That is the image pixel loading capacity. So when our system calculates the loading capacity, it should be a complete rectangular, like the gray part. This is the image pixel loading capacity. So it means in this area, no matter how many cabinets you connected, the loading capacity is the same. So in this case, no matter you connect 9 or 8 or even 7 cabinets, in the gray part, the loading capacity is the same. Okay, now let's get back to the real client case. But the customer only has one M-Control 660. So does it mean the M-Control 660 cannot work? Here, don't worry, we can try to do another screen connection like this. After calculate, we can use port 1 to load 1, 2, 3, 4, 5, 6, 7, 8 cabinets in the first line. And port 2, we use it to load the 8 cabinets in the second line. And port 3, we use it to load 8 cabinets in the third line. And for the port 4, we use it to load 6 cabinets on the right side. Okay, then we click Send to Hardware. This time, successfully. Okay, so this is the final solution. We can finish the basic structure like this. So from this case, When we are designing a solution, we should not only consider how many cabinets each output port can load, and also we need to pay attention to the screen connection logic. It should be a complete rectangular. Now, let me do a summary here. Today, we have learned the smallest unit of the LED screen, the basic structure of the LED control system, and how can we calculate the loading capacity. And at last, we also learned how to design a solution. So all these are very basic but very important information for you to remember. I hope all of you got it. Okay, so this is the basic knowledge of a NovaStar control system. So if you have any questions, leave us a message. And also, we need your feedback here. Now, let's get into our Q&A part. I'll hand over this part to our experienced technical engineer, Darren. He will answer all the questions you have posted on the message zone. And during this process, you can still post the questions you want to know if you like. Okay, now we will take around 1 minute to get all this ready. Thank you.